now that we've defined this first physical quantity, the displacement, as, if you'll remember, delta x equals x sub f minus x sub naught, we can begin to work some examples and look at every possible thing we can do with this equation which we've written here. The first simple way that we can look at this equation, first example that we can work, involves no algebra. It's just plugging in numbers. So for this example, we say, hey, a particle begins at x sub naught equals 1.7 meters. It's going to move to x sub f equals 5.09 meters. And we ask what the displacement is. Well, we have both quantities. We just plug it in here. And you're going to have to bear with me because I'm going to plug these numbers into a calculator. But I have x sub f equals 5.09 meters. And I have, for that x sub naught, 1.70 meters. And if I plug it in my calculator, as you will do, what I find is that displacement, delta x, is just equal to 3.39 meters. Like I said, this is a great example because there was no algebra involved, but let's do one that's a little more involved. Again, remember, the equation that I'm concerned with is delta x equals x sub f minus x sub naught. In this case, we're told x sub naught is 6.88 meters, and we're moving to x sub f equals 1.25 meters. Well, again, I've given you a simple example where there's not going to be any algebra. The excitement here is going to occur because x sub naught is greater than x sub f, so we'll see that we're going to have a negative displacement of, x sub f minus x sub naught. Remember, x sub f is 1.25 meters, and x sub naught is 6.88 meters. And this is going to give us an answer of minus 5.63 meters. And we have a negative sign. Remember, displacement is a vector. It has magnitude and direction. Here the magnitude is 5.63 meters, and negative is going to tell us that we've moved from some point on the x-axis to a position that's left of where we began. Let's see what happens in example 3. All right, here we're going to do what I was implying before. We're going to have this equation, delta x is equal to x sub f minus x sub naught. But in this case, instead of being given x sub f and x sub naught, we're told x sub naught and the displacement, delta x. We're asked to find x sub f. And the way we do that is we rearrange these terms so that x sub f, that thing we're looking for, is going to be located on, to the left of the equal sign. If we add this x sub naught to each side, what we'll find is that x sub f is just equal to delta x plus x sub naught. So we have to reach back and remember our basic algebra and our basic algebraic operations. Now we're ready to plug in our numbers and see what answer we have. This is something very common too, and we're going to be doing a lot of algebra and a lot of calculations. Remember to always get a formula for the number that you want. Always isolate that variable that you're concerned with, in this case x sub f, and then when you've got this expression on the right hand side, only then put in your numbers. In this case, our displacement was 2.0 meters, and that initial location was 6.88 meters. This one's simple enough that I'm going to do it in my head, but always check my numbers. Never trust any numbers that you're given, whether I do it or whether it's in the book. It's always good to go through and check that these things are true. But what we find here is that x sub f is going to be equal to 8.88 meters. And so we've gone through the different ways of looking at this equation. Just at the very final note of this, I want to say that when I had that delta x was equal to x sub naught, I'm sorry, and I got them reversed. It's going to be equal to x sub f minus x sub naught. Well, in this case, we wanted to isolate x sub f. You could have isolated x sub naught as well, and I'll just write out what the answer would be. Just remember that whenever you're asked a question that's going to involve this equation, this definition of displacement is some final location minus an initial location, there's going to be different things that you could solve for depending on which variables you're given. So always be prepared to read your problem statement, find the equations that are relevant for solving the problem, and then do your algebra before plugging in those final values.